Hey guys, today we're going to focus on absolute value equations and absolute value inequalities. So we'll start with section 1.4. Let's recall that absolute value is always positive because it represents the distance a number is from zero on a number line. So absolute value is always positive. Okay? One other thing we really want to remember in these problems here is that we have to watch for extraneous solutions, special cases, ones that may not make sense or work. So let's get started with absolute value equations. There are some steps that you want to make sure to follow when doing absolute value equations, and they're listed here. Number one, we're going to isolate the portion of the equation with the absolute value bars. So we want to get the absolute value bars completely alone, everything else to the other side. At that point in time, it's a good time to analyze the situation. Maybe you catch something funny. Maybe you can see, oh, this is a special case, and we'll look at some examples of that. After we have the bars isolated, we're going to drop the bars, and we're going to set two cases, one to the given answer and one to the opposite. Once we have those two cases, we'll solve both of them. And then lastly, we always want to check. And that's where steps 2 and 5 kind of come to play. You may have analyzed the situation and know your answer, but if you just kind of run through the steps, you have to check to see if you have an extraneous solution. So let's get started. Let's do numbers 2 and 3 together, okay? And I'll have you do numbers 1 and 4 on your own. So for number 2, the first thing we need to do is we need to make sure absolute value is alone. Notice there's a 2 out front and this -1. So the first thing we're going to do is we are going to add 1 to both sides. This now gives me 2 times 3x minus 5 equals 8. We'll divide through, and that gives me absolute value of 3x minus 5 equals 4. So at this point in time, I have my bars isolated. I'm going to analyze. And remember, absolute value is always positive. Look at this answer. It's positive 4. So this is an equation that can be true. So from here, we're going to drop those bars and set two cases. I'm going to go do it over here. My first case is going to be 3x minus 5 equals 4. And the second case is going to be 3x minus 5, but this time it has to equal -4, the opposite answer. If it had been -4, now I'll make it positive 4. And so let's solve those. We'll add 5 to both sides. This gives me 9, x equals 3. We'll add 5 here. This gives me 1 divided by 3, x equals 1/3. So here are my two solutions, and we're going to try to write those in sort of set notation here. We have two solutions, so we use our brace. I like to go from least to greatest, so 1/3 and 3 are my solutions. Okay, and there you have it. Let's look now at number 3. Number 3, first thing we need to do is make sure the bars are isolated. I have this 4 right here, so I'm going to subtract 4. I now have absolute value of 6 minus 4y equals -4. I isolated the bars, and here's a good spot to analyze. It's saying that this absolute value equals -4. No matter what I plug in here, will I ever get a negative solution? Remember, absolute value is positive, so I will never get a -4. No matter what I plug in here, finding an absolute value means make your answer positive. So right here, I actually know this answer is going to be no solution. That's why I really encourage you to analyze. However, if you forgot, we can continue with our steps. So the next step would be to drop the bars and set the two cases. So 6 minus 4y equals -4, and 6 minus 4y equals positive 4. Okay, if we solve those, we would subtract 6, we get -4y equals -10. So y equals negative 10 over negative 4, which is 5 halves. This guy here, we'd subtract 6, and we would get negative 2. And y would equal 1/2. Remember, the solutions always need to be checked. So let's check these. Let's actually plug them in. If I plug in 5 halves here, let's scroll down a little so we have room. I would have the absolute value of 6 minus 4 times 5 halves plus 4. And we want to know, does that equal 0? So we'll solve that. This gives me the absolute value of 6 minus 10 plus 4. Again, does that equal 0? 6 minus 10 is negative 4. But remember, we're taking the absolute value. So the absolute value of negative 4 is positive 4. Does 4 plus 4 equal 0? No, it does not. So therefore, this is a no solution problem. Okay, so your checks, even if you forget to analyze, you may get these two answers, but you always have to check to prove that they are correct. Okay, same deal. We could plug this one in and it will give me a false answer. So go through and check all your problems, but the key thing is to always analyze, because right away I knew, right from this start, no solution. And it's okay if right then and there you can determine no solution. You can say that right then and there. Okay? All right, you can pause the video and work on numbers 1 and 4 to fill those in. Now let's continue with inequalities. So absolute value inequalities and compound inequalities. So if we have a compound inequality, it just really means 2 or more inequalities. Our compound inequalities use the words and or. Okay? An and inequality is much more restrictive. Both have to be true. Ors are one or the other. So for example, I can't be red and green at the same time, but I could have a red or a green crayon. So notice, ands are more restrictive, ors are more broad. Okay? Keep that in mind when we're looking at our special cases and the answers that would make sense. So let's look at numbers 2 and 3 together here, and you can go back to do number 1. So number 2, we don't see any words here, but I do see 2 inequality symbols. When there's not a word, it's an and statement. So you could really have this be the same thing as 2x minus 2 is greater than 4 and 2x minus 2 is less than 10. But it's okay just to work with this as is. The whole thing is we're going to get that x alone. So I'm going to add 2 to get rid of that, and I'm going to add it everywhere to each side of the inequalities. Okay, that gives me 6 is less than 2x, which is less than 12. Continue on, divide by 2. And we get the following. Okay, so let's understand what that's saying. What is that saying? That's really saying x is greater than 3, right? I'm opening up to the x, so x is greater than 3 and x is less than 6. And is that a possibility? Can I be greater than 3 and at the same time less than 6? Yes, right? 4 is greater than 3 and at the same time less than 6. So this answer does work. We're going to write that in our set notation. So we're going to have our brace. Our variable is x. So we're going to have x such that, and then exactly what we just had there. So there's my solution. And now let's talk about a number line. So on my number line, we definitely want to have 3, 4, 5, 6, and I like to include at least 1 on each side as well. Okay, I'm going to grab a different color here. And now we want to graph that. So it's saying that I am greater than 3. Remember, I'm not greater than or equal to, I'm just greater than. So I'm going to have an open circle on 3. And if I'm greater than, that means I'm going towards the right. But I have to be at the same time less than 6 because it's an and statement. So I'm going to be greater than 3, but and at the same time, I must be less than 6. So I have an open circle on 6, and we're just connected there. Okay, let's take a look at number 3. Number 3 is an or statement. We can see right there that it says or. So we're just going to take these as two inequalities as they are. Let's first solve the first one. Subtract. I'm going to get our variables to one side. So I'm going to move this x over, and that's going to give me a single x. Plus 1 is less than negative 3. Subtract the 1, x is less than negative 4. Now we'll simplify this. We'll distribute. 3x plus 3 is greater than x minus 15. This will give us 2x is greater than negative 18. And this is that x is greater than negative 9. Okay, double check that work. 3x and 3, subtract our 3, subtract our x. Okay, so here we have it. And remember, this is an or statement. So if I look at my number line here, it's saying I should be less than negative 4 or greater than negative 9. So if we have our number line, remember negative 9 is really smaller. And I'll add negative 3 and negative 10 here. Okay, take a different color. So I need to be less than negative 4. So here I am, less than negative 4. That would mean to go to the left. This time it's an or statement. So it's saying I need to be less than negative 4 or greater than negative 9. Well, because it's or, remember that's more broad. It's not saying I have to also be greater than negative 9. So I don't need to stop at that negative 9. I can keep going. And same deal. I was at that negative 9, but I can be greater than it, and I do not have to stop at the negative 4. It's saying I'm one or the other. So notice what I have here, okay? I'm going to actually get rid of these open circles, right? I don't need, whoops, let's see if I can fix that. I don't need the open circles at all. I'll just fill them in because, sorry, technical difficulty there, because we can include those. So what I really have here is the entire number line. No open circles, and everything on my number line is plotted. If everything on my number line is plotted, what that means as my solution is what? It means that all real numbers work. So let's make sense of that one more time. It's saying I'm less than negative 4 or greater than negative 9. So if I pick a value less than negative 4, that could be negative 100. So is negative 100 less than negative 4 or greater than negative 9? Yes, negative 100 is less than negative 4. It does not have to be both. Vice versa, if I'm greater than negative 9, that could be 2. So does 2 fit this solution? Is 2 less than negative 4 or is 2 greater than negative 9? Yeah, doesn't fit this, but it does fit the fact that it's greater than negative 9. That's where we get all real solutions. And that's where we want to watch those special cases. And a big indicator for a special case is looking at the graphs. Ands should connect and ors should go in opposite directions. If they all connect or don't connect at all and they're supposed to, that's where you should have the red flag. Okay, go back to do number 1. All right, now let's take a look at absolute value inequalities. So for our absolute value inequalities, we're going to recall the same steps we used for our equations, okay? So the first thing we have to do is get those absolute value bars alone. So to do so, we would add 2, Now that they're alone, we're going to drop those bars. 2y minus 4 is less than 18 is one case. And my second case is going to be that it is greater than negative 18. So notice here, when I changed the second case to the opposite sign, I also changed the inequality symbol. And that's because when we multiply or divide through by a negative 1, it has to flip the symbol. So here are my two cases. The other thing to check for, and I'm not going to use a line so it doesn't get confusing, is to check for this symbol right here. Notice I circled it once the absolute value part was alone. When the absolute value part is alone, I want to analyze that symbol. That symbol being a less than right there is going to cue me in that this is going to be a and statement. So I know I can put an and between here. That's going to help me out with those special cases. Okay? If it had been a greater than symbol, then it would be an or statement. One thing to just keep in mind. So now let's solve those. We would have 2y is less than 22, y is less than 11. This one here, we would have 2y is greater than negative 14, and y is greater than negative 7. Now let's look at that. Let's analyze. It's an and statement. Can that be true? If y is less than 11 and at the same time greater than negative 7? Yeah. For instance, 0, right? 0 is less than 11 and at the same time it is greater than negative 7. So we do have solutions. So I'm going to write that as a solution set. And because it's an and statement, I like to combine them. So it's going to be y such that y is greater than negative 7 and less than 11. Now let's graph that on a number line. Don't need to put all the numbers here. I'm going to put 0, negative 7, and 11. How about that? Okay. We'll take a different color. And let's graph. So y is less than 11, open circle. And at the same time, it has to be greater than negative 7. So I can't keep going. I have to stop. So there's my solution for number 4. Remember, this is a nice normal case, no special case. I could always analyze back up here, right? This is saying an absolute value being less than positive 18. Yeah, right? Absolute value is positive. I do have some positive numbers less than 18. So there are some possible solutions. Wouldn't be every solution, right? Because you can't have negative answers, but I would get a bunch. And that's what demonstrates my solution there. Okay, how about number 7? Let's look at number 7 together. So, number 7, we want to get the absolute value alone. So we have subtract 7. That gives us negative 4. And I'm a big advocate to have that absolute value reading on the left-hand side, or your variable reading on that left-hand side. So I'm going to switch that. I'm just changing the order. I'm not dividing through where I have to change symbols. But notice right here, it's absolute value is pointing to the inequality is pointing to the absolute value, so I need to keep that there. Okay? Now, right here to me is a big red flag. What do you know about absolute value? Absolute value is always positive. Can a positive number ever be less than a negative? No, it never can. So if a positive can't be less than a negative, what does that mean this is telling us for our solution? This is telling us that we will have no solution. So your number line would be an empty number line. There's nothing to plot. So always analyze to make sure your absolute value is going to be a positive answer. We can never have a positive answer being less than a negative.